Hi everyone, this is Dr. Gray here, and today we are working on waves target 4, understanding how waves act and interact, understanding that the behavior of waves is caused by reflection, refraction, and absorption, and understanding how reflection and absorption produce color. And so today we're going to focus on reflection, but particularly we're going to look at specular and diffuse reflection. What are they and how are they similar and so forth. So for starters, reflection occurs when waves bounce off of a surface. Now, we're not just talking about light waves, we're talking about all kinds of waves. So light waves obviously bounce off of a surface. This is what gives us colors or images from mirrors. Sound waves reflect off surfaces. This is what gives us echoes. Water waves bounce off surfaces when they collide with rocks or walls of that sort. And seismic waves even reflect off surfaces when they come in contact with a solid boundary that does not allow that wave to be transmitted through. That wave reflects as well. And so waves follow the law of reflection. A law in science is simply a statement of something that is always true and can be demonstrated. So simply stated, the law of reflection is the angle of reflection equals the angle of incidence. So here in the diagram above, I'm going to show you what that looks like. And so here at the bottom, this is our mirror or our reflecting surface. Today we're going to look at it as a mirror. So this is a plane mirror. It is the same kind of mirror that you have probably in your bathroom at home. And the first piece that we want to look at is this line right here, or this dashed line. This line is referred to as the normal. And the normal is an imaginary line perpendicular to the reflecting surface. And so if we were to measure this angle right here, that would be a 90-degree angle. When a wave strikes a surface, we call that the incident wave, and it makes an incident angle. And so the distance between the incoming wave and the normal makes the incident angle. And so we're just going to use the symbol theta to represent the angle, and I for incidence. Now that light wave is reflected off of that surface, and so we also have a reflected wave. So this is our reflected wave. This one over here is our incident wave. And the reflected wave also is at an angle to that normal. And so here we have the angle reflected. And in this case, and in all cases, what the law of reflection states is that the angle of incidence is equal to the angle of reflection. And this is always true, regardless of the type of waves. Doesn't matter whether we're looking at light waves or sound waves or seismic or water waves. It also doesn't matter what type of surface the wave encounters. Could be a smooth surface, could be a rough surface, could be a liquid surface or a solid surface. The law of reflection, like all laws, is a statement of something that is always true. And so the incident angle of that wave is always going to be equal to the reflected angle of that wave. So let's look at how this produces images. When we have a nice smooth surface, like a clear or a pond or a lake on a windless day or a mirror, we have a nice smooth surface. And so these blue rays here, these are our incident rays. And incident light rays are always parallel. And when the surface is smooth, well, our normals for each of those incoming waves are going to be parallel, and our reflected waves are also parallel. Just put that all the way there. And because these waves, because the reflected waves are parallel, the information that is transmitted to our brains is a nice, clear copy of the original. And so if we look at this mountain peak that's reflected off of this watery surface, well, the reason that surface, or the reason that image, or that reflected image is nice and crisp and clear is because the reflected light waves that are entering your eyes are all parallel. They're all coming in the same way, and so they're all giving your brain the same kind of information. Now, if we look, when the reflected rays are parallel, the reflected image is an exact replica of the original. Now, what if that surface isn't smooth? What if it's a breezy day and the surface is now rough instead of smooth? Well, the law of reflection still applies, except now the reflected rays are not parallel because of that rough surface. Now we have a surface. So there's my rough surface. Imagine we're zooming in real close. And so here we have incident ray, incident ray, incident ray, and those rays are still perpendicular. But now, because this surface is not smooth, we have our normals are not parallel. And so if we're looking at this location right here, well, right now, that would be the angle of our surface. And so perpendicular to that is kind of like this. And so our reflected ray for this first incoming ray goes this way. And then for our second, well, now our surface looks like so. And so our normal is up here. Maybe I'll do these in blue, our reflected rays. So this was our first reflected ray in blue. And now our second reflected ray, if we keep that reflected angle equal to the incident angle, well, there's our second reflected ray. And if we look at our third one, our third incident ray, well, now the surface is pointing that direction. Our normal is right there. And so our reflected ray in this case is going this direction. And because these reflected rays are not parallel, now we don't get a clear image. Our brain gets the information that, yep, there is incoming light waves, but because the rays aren't parallel, the information is essentially scrambled. And so we get color. We might get the idea of a shape, but we don't get clear details. When the reflected rays are not parallel, then the reflected image is not an exact replica of the original object. Our brain is given some information. We know that there is something there, but the information that it is given is not sufficient for us to make out exactly what is there. So if we wanted to fill out the compare and contrast matrix for specular and diffuse reflection, well, the relationship of the incident angle to the reflected angle in specular reflection, they are equal. In diffuse reflection, they are still equal. The reflecting surface in specular reflection is perfectly smooth. During diffuse reflection, the reflecting surface is rough. The quality of the reflected image in specular reflection is a perfect image. Whereas in diffuse reflection, the quality of the image, well, now it is blurred. And this is true even if we are looking at, say, a wall. If you look at the walls in the classroom, well, you can just see the color of the wall. You can't see your image reflected in that wall. And again, this is because the surface of the wall is rough. And so the reflected light rays, like the ones in diagram B over here, the reflected light rays are going every different direction. And so the only thing that our brain takes away from it is the color of the wall. None of the images are reflected in that surface because it's got a rough surface. If we were to look at it very close, its surface would be closer to what we see in sample B. So that covers it for specular and diffuse reflection. Your follow-up to this lesson is I need you to write me a paragraph summarizing what you've learned about reflection. In this paragraph, I want you to make sure that you tell me what's happening during reflection, what are the different types of reflection, and how are they similar, how are they different, so that's where you're comparing and contrasting the two types of reflection. And then give me examples of both types of reflection for two or more types of waves. So you could talk about reflection of light waves, you could talk about reflection of sound waves, you could talk about reflection of seismic waves or water waves. And so the first three bullets here, those are your paragraph must contain that information. Now, I would also like to know, what did you find most interesting about reflected waves? What would you still like to know more about? And what are some parts of it that you're still confused about it? If you would like, I would appreciate any information that you could give me about you in your paragraph, but these are optional. These are not requirements of that paragraph. That's it for today. I'll see you in class.